Okay, so the last thing that I want to do with implicit differentiation is come back to something that I put off a long time ago. Y equals ln of x. So we all know the derivative of y equals ln x is 1 over x. But why? It's actually surprisingly easy to show that now that you understand inverse functions and how to use them with implicit differentiation. So if y equals ln x, and what I'm about to write is, it's extraordinarily important that you understand that this is how inverses work. Ln of x and e to the x are inverse functions. What that means is that if y equals ln of x, then e to the y equals x. That's the meaning of inverse functions. That's in a certain ways the definition of ln. It's the inverse of e to the x. All right, so now I have e to the y equals x. So now I can do my implicit differentiation. Derivative of e to the y is e to the y, but since it's a chain rule, I'm going to pick up dy dx, and on the other side I have 1. So dy dx equals 1 over e to the y, and e to the y was x, so oh my god, look how easy that the derivative was 1 over x. All right, so but let me show you another cool thing. So suppose instead of y equals ln of x, I had y equals ln of negative x. All right, just for kicks, let's see what's the derivative of that going to be. I mean, I think you could probably do chain rule on that. Actually, it would probably be the easiest way to do that. We could do the same thing we did up here. That's how I originally did it. But, you know, on second thought, oh, there's so many interesting ways to do that. Let's do chain rule. So dy dx is going to be, so when I do derivative ln of negative x, I'm going to have 1 over negative x, right? So that's keeping the inside function the same. I was going to do this a different way, but this obviously is a lot easier. And then g prime is going to be negative 1, so I get positive 1 over x. All right, so this result up here, you knew dy dx is 1 over x. What we're adding in is the derivative of ln of negative x is also 1 over x. So we can expand what we already knew, which is the derivative of ln of x is 1 over x. We can expand it to say the derivative of the ln of absolute value of x is 1 over x. Now, when we're just doing derivatives, we're not going to care about the absolute value. We're only going to care about the derivative ln of x is 1 over x, because we're not usually going to have derivative ln of absolute value of something, okay? But when we go to do antiderivatives, where we're going to know what the derivatives and we need to know what the function it came from, then this absolute value is suddenly going to become important, okay? So that's something we got coming up later. For now, this is all I really wanted to show you, is how easily we can show that the derivative of ln x is equal to 1 over x. All right, now more things that I want to say are that your homework is page 170, number 13 through 27 odd, and page 181, number 25 and 27. Okay, here's another fun thing to consider. This concludes our work in chapter 3. If you look at your book, this is 3.8, derivative of inverse trig functions. All right, the next section, 3.9, derivatives of exponential and logarithmic functions. Hey, we already did that. I wonder what the next section in chapter 3 is. Oh, there isn't one. The next section in chapter 3 is called chapter 4. So in chapter 4, our next chapter, we're going to do these applications. It's going to be really awesome. All right, but and I'm going to start that actually on, what is it going to be, Friday or whatever day it turns out to be. It's going to be this week. We're going to already start chapter 4. But we need a test on chapter 3. So presumably that is going to happen next week. But to be honest, I not only have not figured out when to do this test, I have not figured out how to do it, because my old tests aren't quite going to cut it. I have to come up with something new, and the kind of weird things I've been doing for quizzes and such. I haven't got any ideas yet, but I'm going to try and figure it out this weekend. But just know that this is coming probably next week, possibly as early as Friday if I figure it out. All right, now what do you need to know for that test? Well, you need to be able to know everything that's on the quiz. So, basically tangent lines, the relationship between f and f prime, the higher derivatives and what they tell you, motion problems. And now I can say, for the first time this year, you need to know everything on this chart, both sides. All right, because we got everything. Now, just a quick heads up, as you go forward into your college classes, you're going to find most people don't necessarily memorize these inverse sine, inverse cosine, inverse secant, inverse cosecant, inverse cotangent. But everything else on here, everybody's going to walk into that Calc 3 class in university, and they're all going to know all those. If you ask them what's the derivative of tangent, they say secant squared, and you need to be one of those people. You also need to know inverse tangent derivative is 1 over 1 plus x squared. You're going to know that really well by the end of the year because we're going to use it for a ton of other things. So you want to be, so as far as the inverse sine, inverse cosine, you just want to know, yeah, there's a formula for that. It involves some kind of a square root in the denominator. I'll look it up online. All right, that's the most anybody's going to expect out of those for the most part. If you love to memorize stuff, then memorize the whole thing, but not many people do. But make sure you know this one and all of these, and definitely all of the back. So that's it for chapter 3, people. I'll work on developing a test, and on presumably Friday, we start chapter 4.